So our last section of this curriculum is our 9.8, solving quadratic inequalities. And our learning objectives from this section are solving our quadratic inequalities algebraically, being able to write our solutions in interval notation, and then being able to interpret those solutions graphically. So in order to solve a quadratic inequality, what do we have to do? Our first step that a lot of students forget, and I will often make this mistake sometimes too when I'm teaching it to you guys and I'm going through it really quickly, moving everything to that left-hand side so that right-hand side is set to 0. Then from that point, you are able to factor that left-hand side or utilize your quadratic formula and find the zeros of your quadratic expression. Once you find those zeros sort of represent your critical numbers or critical values. And then we put those critical values on a number line and test the ranges between each of those critical numbers. Now, once you're able to get to testing those values, you might find that between negative infinity and let's say this is 4, you have all negative values. Between 4 and 100, you have all positive values. And between 100 and positive infinity, you have all negative values. And so if you're looking at values where this quadratic function is greater than 0 means positive. So essentially we're looking at this range of values, which leads us to our last step, writing in interval notation, which just is simply 4, 100. And then because it's not underlined here, we're going to have soft brackets because we're not including where it is equal to 0, only where it's greater. We'll do loads of concrete examples. So if you did not understand what I just said for the past 30 seconds, that is okay. This is just the steps these are just the steps that we're going to be running through. So now knowing that, this is going to be our first concrete example that we'll tackle together. Lucky for us, we have everything all over to that left-hand side already. So we can immediately just jump into solving for our zeros. And how do we do that? If we can factor, bless you, then let's go ahead and factor. What are factor pairs of negative 30 that add to 1? We have x plus 6 and x minus 5. Positive 6 times negative 5 gives you negative 30. Positive 6 plus negative 5 gives you positive 1. Good. What does this tell us? This tells us that our x values are negative 6 and positive 5. AKA, these are our critical numbers. Which leads us to our next step where we create our number line in order to test these values. More specifically, test the ranges between these values. We have between negative infinity and negative 6. We have between negative 6 and positive 5. And we have between positive 5 and positive infinity. So now all we have to do is choose a value between each of these ranges and see, does it spit out a negative number or a positive? At the critical numbers, we're going to put little circles. Because if our x value is equal to negative 6, we shoot out 0. If it's equal to positive 5, we shoot out 0. Now we want to ask ourselves, do we want that right-hand side to be just less than 0, or do we have it set where it's less than or equal to 0. Because it has a line underneath and it's less than or equal to it, do you think these should be open circles or do you think we should fill them in? Are we including 0 in our solution set? How many people think, yes, we are? Yeah, we are, right? Because it's equal to 0, we're including 0. And so if we want to include 0, we need to fill in the values that make that left-hand side 0. So they're going to be closed circles. Now we can go ahead and choose our range or our test points. A value between -infinity and -6. Just going to choose -7. When I plug in -7 for x, I get -7 plus 6, that's -1. And then I get -7 minus 5, that's -12. A negative times a negative gives you a positive value. So we end up with a positive in this range. We don't have to solve for the exact number. We just need to figure out, is it positive or is it negative? Now let's jump to here. What's a value between -6 and 5? Always choose easy values. 0, right, falls between those two numbers. So we plug in 0 for x and we get 6. We plug in 0 for x here and we get -5. Positive 6 times -5 gives you a negative value. And now we're going to choose what's a number greater than 5, 10. 10 plus 6 is 16. 10 minus 5 is +5. A positive times a positive is indeed a positive. Almost done. We're at our last step. Now we want to figure out, okay, this quadratic, what are the solutions when we're looking at it being less than or equal to 0, aka when our values are negative or 0. And so all we have to do is highlight the range where it's negative on our number line. That gives us our answer. So we just have to put that into interval notation. So our solution in interval notation is the following. They're closed circles, so we're going to have hard brackets. -6, comma, +5, hard bracket. And we're done. So this is literally what we're going to be practicing throughout the entire class today. Any questions on this? Again, very systematic. Step 1, set everything to the left-hand side to be your quadratic, to the right-hand side to be 0. Step 2, factor that left-hand side if you can, or use quadratic formula. Identify your critical numbers and figure out, are they open circles or closed circles based off of your inequality. It would also be an open circle if, let's say, this was a fraction and you had something in the denominator where the x value would be 0, that would be an open circle at that point. Then create your test values to test out positive and negative, and then highlight your solution, put in interval notation, and we're done. And this was just sort of the written out solution that we got on this page. All right. Let's try example 2 together. Now you'll notice with example 2, Everything's not on that left-hand side. So what do we have to do? We have to first add 14 to both sides so that we get that right-hand side equal to 0. We end up with x squared plus 9x plus 14 is greater than 0. Because it's just greater than 0, we're going to end up with some open circles in our number line, something to just think about. Second step, we're going to factor that left-hand side if we can. What are factor pairs of 14 that add to 9? We have 7 and 2. So we have x plus 7, x plus 2. Third step, this tells us what our critical numbers are. X's are equal to -7 and -2. So now we can move to our fourth step and we can create our number line. Because it's greater than 0, not greater than or equal to, we're going to have open circles at those critical numbers. And now let's choose a number between -infinity and -7, -10. Plug in -10 here, we get a negative value. Plug in -10 here, we also get a negative value. A negative times a negative gives you a positive. A value between -7 and -2, -3. If we plug in -3 here, we get a positive value. If we plug in -3 here, we get a negative, and a positive times a negative is a negative. What's a value greater than -2? 0. Plug in 0 here, we get positive. Plug in 0 here, we get positive. Positive times a positive is a positive. And then we look at what's highlighted in pink. We're looking at all values that are greater than 0, aka all of our positive ranges. So we're looking at all of this and all of this, and it's open circles. So our final step is we want to put our solution into interval notation. So soft bracket all values from -infinity to -7, soft bracket, because we're not including that -7, union all values from -2, again, another soft bracket because we're not including that -2, up to positive infinity, and we're done. Anytime we're dealing with infinities, it's always going to be soft brackets. Because infinity is not a number, it's a symbol that represents the continuation of the real number system. Any questions on this at all? How do you guys feel? Scale of 1 to 5, 5 being getting the hang of it more. We'll practice it a bit more and then I'll ask you guys again. I feel like you get it even more. Again, this was just the solution. Okay, let's try example 3 together. Once again, we want to move everything to that left-hand side. So we're looking at x squared plus 6x plus 4 is less than 0. And then we want to ask ourselves, can we factor this? And can we? Well, it doesn't factor quite nicely. So we need to use our quadratic formula in order to find our zeros. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Our a here is equal to 1. Our b is 6, and our c is 4. So when we plug this in, we get x is equal to negative 6 plus or minus square root 6 squared, which is 36, minus 4 times 1 times 4, which is just 4, all over 2 times a, which is just 2 times 1. Let's zoom in on this. So we get x equals negative 6 plus or minus square root of 36 minus 16 all over 2. 36 minus 16 is 20. And the square root of 20 can be broken up into the square root of 4 and the square root of 5. So we're really looking at negative 6 plus or minus 2 square root of 5 all over 2. And we can factor out a 2 from each term. 2 goes into negative 6, negative 3 times. 2 goes into 2 once, and 2 goes into 2 once. So we can rewrite this as x equals negative 3 plus or minus 1 square root of 5 is the same as just square root of 5. So these are our two different roots. Now that we have that, we can now go into, once again, our number line. Infinity, positive infinity. We have our negative 3 minus square root of 5. And then we have negative 3 plus square root of 5. And so the square root of 5, well, we know the square root of 4 is 2, and we know the square root of 9 is 3. So I'm assuming it's like around 2.1 or 2.2. That's like a good estimate. Let's just use 2.1. And so we're doing negative 3 minus 2.1. That will give us like about negative 5.1. So about negative 5.1. And then if we do negative 3 plus 2.1, we're looking at about negative 0.9. So essentially, what do we have to do? Let's choose a value between negative infinity and negative 5.1, but let's be conservative. So I'm going to choose like negative 10. And then I'll plug that into our left-hand side. Negative 10 squared gives us positive 100. Negative 10 times 6 gives you a minus 60. And then plus 4. So we're going to end up with a positive value. It's going to end up being 44. So anything within this range is just positive. You can definitely do this question without a calculator. Just have to make good estimates. Now let's choose a value between these two. So between negative 5.1 and negative 0.9. Again, be conservative. So I'm going to just choose negative 2. And so negative 2 in parentheses squared turns to positive 4. 6 times negative 2 is negative 12. And then plus 4. 8 minus 12 gives you a negative value. So between these two, we have negative. And then let's choose a value between negative 0.9 and positive infinity. Again, be conservative. I'm going to choose positive 10. 10 squared is 100. 6 times positive 10 is 60 plus 4. All of this is going to give you a positive value. And because the inequality is saying all values that are less than or equal to 0, we're going to have open circles at our critical numbers because we're not including those boundary points since there's no line underneath. And we want to look at our negative range, which is right over here. So our very last step, once again, is just putting that into interval notation. So our solution in interval notation, soft brackets, because we're not including the boundary, negative 3 minus square root of 5, comma, negative 3 plus square root of 5. And once again, soft bracket, because we're not including the boundaries. And that's it. That's your answer. Again, this is free game for the final exam. However, I will say, in all my years of teaching, I've never seen them give you a question like this involving radicals. They're usually a little bit more lenient with you guys. However, you should know how to do it. Any questions on this one? No. Let's do another example together. And in this case, I mean, I personally don't like having a negative a value. So what I actually would do, you don't have to do this, but I'm gonna add everything and bring everything over to that right-hand side. I'm adding 2x squared to both sides. I'm subtracting 5x from both sides, and I'm subtracting 3 from both sides. So this all cancels out. And so essentially, we're looking at 2x squared minus 5x minus 3 is less than or equal to 0. And if we rewrite it where that's on the left-hand side, that's just 2x squared minus 5x minus 3 is less than or equal to 0. We need to make sure that point stays next to that whole quadratic. Okay, now we can go ahead and factor if we can. So let's utilize our AC method to see if this works. Our 2 times negative 3 is negative 6. What are factor pairs of negative 6 that add to negative 5? It does work, right? We have negative 6 and positive 1. So what can we do? We can keep the first and last values the same and manipulate that 5x into negative 6x plus 1x. And then utilize pulling out a greatest common factor. Those first two terms, we can pull out a 2x so that we're left with x minus 3. And then from those last two terms, we can pull out a 1 so that we're left with x minus 3. If we did it correctly, what we have inside the parentheses should be exactly the same. And we're in luck because it is. So now we can pull that out, our whole factor by grouping method, which I see on the final exam all the time. Move this up a little bit. So we're essentially looking at this x minus 3 in parentheses and then 2x plus 1. It's less than or equal to 0. So what are our roots or our zeros or our critical numbers? They're all synonyms of one another. We have x minus 3 set equal to 0, which tells us that our x equals 3. And then we have our 2x plus 1 set equal to 0, which tells us that subtract 1 from both sides, divide both sides by 2. So x is equal to negative 1/2. Because it is less than or equal to 0, we are going to have closed circles. So let's create our number line. Actually, I think what I might do is I'll put my number line up here with more space. Negative infinity, we have negative 1/2, we have positive 3, and we have positive infinity. Once again, closed circles because our inequality has a line underneath it. And then let's choose some good test points. So value between negative infinity and negative 1/2. Let's choose negative 1 and plug that in. If we plug in a negative 1 minus 3, that gives you a negative. 2 times negative 1 is negative 2, plus 1 is negative 1. So this is also negative, and a negative times a negative gives you a positive. What's a value between negative 1/2 and positive 3? 0. So plug in 0, we have 0 minus 3, that's negative. And we have 2 times 0, which is 0 plus 1, that's positive. A negative times a positive is a negative. And what's a value greater than 3? 10. 10 minus 3 is positive. 2 times 10 is 20 plus 1 is positive. A positive times a positive is a positive. We're looking at where our values are negative and 0. Look at our negative range since it's less than 0 or equal to 0, so or 0. And so this is the range we're looking at. And then finally, let's put our solution into interval notation. Since they are closed circles, we're going to have hard brackets from negative 1/2 comma, 3, another hard bracket. And that's it. That completes this problem. Now, how do you guys feel? Scale of 1 to 5. I would say if you're still like 3 and below, definitely try to practice it a bit more. And even if you're at a 4 or 5, try to practice a few of them tonight on your own so that you really get a good grasp of it. Right. So the key points from this section, we want to remember that our inequality sign, we didn't really see it this often, but our inequality sign will flip when you multiply or divide by a negative number. So I'm actually going to highlight that because that is a very important point. And then we always have, we need to test at least 1 point in our interval in each of the intervals to see where is it positive, where is it negative. Then for the inequalities that have underlines, we want to include the zeros in the solution. Where it's not, we're excluding it. So what does that mean? We have open circles here. And we have closed circles here on our number lines. The only thing you do need to be on the lookout for is if we're dealing with a fractional inequality, which I might do an example with you guys in a moment on that, then you also have undefined values. And where those critical numbers are undefined, those are also open circles. So I'll make a side note of that. If dealing with fractions, you might have undefined x values, which will also be open circles on your number line. So that concludes the PowerPoint slide for our section 9.8. I do want to maybe do some of these 9.8 exercises from the workbook. Let's see. Maybe I'll ask you guys. Does anyone want me to solve questions 1, 2, 3, or 4 on this page? And if so, which question? I would say try to choose the hardest one or the one that looks the hardest for you, since we're doing it together. Maybe raise of hands. Who wants to do question 1? What about question 2? Question 3? Question 4? All right. Saw the most for question 3, so let's do that one. So once again, solve the quadratic inequality, express solution in interval notation, and graph on a number line. So in a case like this, what do? Let's utilize our distributive property to get rid of those parentheses on the left-hand side. So we have 2x squared plus 7x is greater than or equal to 0. Do you have to do that step? No, you don't. But it will, I personally think it might come in handy when you're choosing your test values. However, from the original problem, you can very easily identify what your zeros are. So your zeros slash your critical numbers. We have anytime an x is just outside a parenthesis, that 0 is at 0, x equals 0. And then the other one, set your 2x plus 7 equal to 0, which is just 2x equals -7. So x equals -7/2. Now let's go ahead and create our number line. Because it is greater than or equal to 0, are we going to have open circles or closed circles? We close circles. Good. And now let's choose our test values. What's a number between -infinity and -7/2, which is the same as -3.5? Choose -10. -10 squared gives you +100, times 2 gives you +200. And then -10 times 7 is a -70. So this ends up being positive. Now, a number between -3.5 and 0, just choose -1. -1 squared is +1 times 2, +2. 7 times -1 is -7. 2 minus 7 is negative. And then we have a value that's greater than 0. Let's choose +10. And you could also plug it in here if you find that easier. Either one, you would get the right result. So 10 squared is 100. 100 times 2 is 200, plus 70, that's positive. If you wanted to double check that that worked, 2 times 10 is 20. 20 plus 7 is 27, and 27 times 10 is once again 270. So positive. We're looking at values that are greater than or equal to 0, so values that are positive, values in positive range, and 0, which means we're looking at these two values. So our last and final step is putting this into interval notation, where we have -infinity to -7/2. It's a hard bracket because our circle is closed. Union 0, another hard bracket because our circle is closed, comma, +infinity. We're done. Any questions on this? Highly, highly recommend you guys try and do these on your own. And then there's another page as well dealing with same exact procedure. Move everything to one side so that 0 is on that right-hand side. Find your critical numbers by factoring or utilizing your quadratic formula, testing values, put it on your number line, and finally put it into interval notation. So I do want to give you guys time to go over that course survey. So let me put up the announcements again, especially for those who came in late. We have about 10 minutes left of class. So give you guys 10 minutes to complete the survey. Again, it's anonymous, so be honest in your description of how you thought this class was, if I was terrible, if I was good. I'm never going to see who actually wrote what. I'll be able to see what you guys wrote, but again, it's anonymous. I won't see your name attached to your comments. And then once you complete that survey, screenshot it and send an email to me so that I can drop an additional quiz off your grade. I'm going to stop recording now.